In this video, I will try to demonstrate the Azure Machine Learning example using a sample data. So in this exercise, we need to create an Azure Studio, Azure Machine Learning Studio. So previously, I created a computer cluster and then a computer instance for training the data. So I'll go back to the designer and I start by picking a sample data. So the sample data, I'm going to use the automobile price data. And from this data, I'm going to select some columns. So if you quickly see the data here, it is a very general, this is a kind of normalized losses. As you can see, it's not very numbered here. The make is very good. The fuel type is good. Some of the columns are very good, some are not. If they are not good, we're not going to select them. But if you go up here, you can see like the mile per gallon, the highway speed, the price. They are important details. So from here, from the sample data, I'm going to use a transformation here and add a step called selecting. So let me select columns here. So to select, you just need to drag it down here, and here you can edit the column here, and you can use by name. I think it's best if you add all, and then but you don't need the normalized losses. Some of them, you don't select all of them to really. Those you think are important to predict the price of a car when it comes to a new set of data. That's what we are interested in. So once you set that, then you select it, and then the next one is to clean them. So cleaning involves things like, if some of them rows are not complete enough, you can remove them so that it avoids misleading data set. So here I can edit this column and I can say to the columns to normalize. So those important columns like horsepower, the bore, stroke. So these are important. So if this, because they are so important, whenever I see the cleaning mode, if they are not good enough, I will remove the entire row. So this is the minimum missing value, the maximum, the ratio. I'm setting 0 to 1 for now, just for demonstration purposes. So once we did that, then we need to normalize it, normalize the data. So normalizing the data includes things like so using the transform. How do you want to transform? There are so many logistical, mathematical settings here. So I'm going to use a min max here, and then I will use some columns to normalize. I need to do that. So I'm going to type some of them. Simple will days, lengths, widths, height, curve, weight, engine size. So if there is any exaggeration in the figures, for example, I want that figure to be normalized so that it doesn't give exceptionally high or exceptionally low figure. So there might be a mistake when they collect the data, and this would use the minimum and the maximum value and see if it fits peak RPM. I think that is, and then you have the CT I'm using one of the examples from MPG, and then highway MPG, right? So I want to include these columns. So once I include these columns, oh, now I know why, I think. There you go. So once I include these columns, the next step is, so I added, I selected, I cleaned, I normalized, and then I submit this process using a new experiment. So I can say here, auto training one. So this is a display name, and then let me have the input here, input output runtime settings. So I'm going to use a cluster. The cluster, my cluster name is this one. So I selected the cluster. Yeah, that's it. And then review and submit. So this might take a while. So once this is done, the next stage is to train them. So once you normalize the data, so it's still happening here. The next step is to add some algebra algorithm to use some of the data for training, some of the data for validation. So for this, you need to add a few. Sorry, my grammar. So the first thing we need to do is to split the data. So to split the data, you need a split module here. So how are we going to split it? It will randomly split half of the data for training and half of the data, not half, like a percentage of the data. So how do you split it? So you want to split by a fraction. So I want to use the first one, 0.7, 70%, and then random split between the two, or the random seed. The random split is true. The random seed is 1, 2, 3. Split false. Yeah. So once we've done that, then we need to train it. So to train, we need to go back here and get where is the training? So this is a model, evaluation, algorithm output, feature selection, model training. So model training, model scoring, model training. I think I'm oh yeah, here you go. So model training. So here I'm going to train my data, and I pick an algorithm. So train my model, and by this time I'm going to split my normal data and transform my normal data and then split it here. And then once I split it, I'm going to use some of the data, for the algorithm that I'm going to choose. Then we need to pick up a machine learning algorithm. So this is where you have to know your maths a little bit. So for normal linear algebra, we're going to use machine learning algorithm here. It's a very common one. So there are different linear, there's regression, there is classification, and there is clustering. This is another subject by itself, but for now I'm going to use a linear regression, which is very common when you are predicting, when you know we are predicting a figure. Classification is things like, if you have a medical situation and you say, oh, if someone is diabetic or not diabetic, that's called a classification. That's a different kind of algorithm. Or you have clustering. Clustering is when you don't know where it belongs, but if you want to say, okay, I'm going to categorize similar elements into different groups. So this is for marketing purpose, things like that. Anyway, for now, I'm going to put linear algorithm here. And then what I'm going to do is use this linear algorithm to train in the model. So use this linear algorithm for the training. For training, I use some of the data for training. I use linear regression. And once I did that, then what you need to do, you have to score it. Score means, what is the value coming. So how is the training going on? So for scoring, then we go to the scoring section here, and then we pick score model. So what we're doing here is, okay, you split the data using linear, you train it. Then let's have that. Good. And then from the original one, the one that's not split, the 30%, use data to evaluate if really the training model fits with the untested, the validation set of data. So here I have to say, training the price. I have to be very careful here. Price. Save. Yeah, that's good now. So configure and submit. It seems to be going now. I think if I go to the jobs here, yeah, submitted successfully. If I go to the jobs back again, I should see a second one. Yeah, there you go. So this is the first one without the score. This is with the score. So when this is done, we're going to go back and see how it's predicted. We'll see the output. Once we see the output, then the next step is we evaluate it. And then after we evaluate, we're going to publish it. So where is it now? It's splitting the data, as you can see, progressing. The training took some time, but when it's finished, as you can see here, the score model shows the result of the training. So here you can see the output. So if you show the data, if you preview the data here, we can see that. Scroll it a little bit. Let's go again. So here you go, the price. So it shows you the price of the and the score of the validation data. Once that's done, so this is the output of the score, which means the unused split data against the training model. This is the output, and you can see it is reasonable, as in it's within range. So then we need to evaluate this score. To evaluate this score, we need to go to the designer again, and from from the score, they will have to pick up an evaluation model scoring. Evaluation model, here you go. So we need to do some evaluation here. So the evaluation there are so many, the theory is there are so many numerical values to, like, mean errors. For classification, we have things like accuracy, precision. There is a theory behind it. So here, what we're going to do is we're going to connect the output of the score to the evaluation model. Yeah. So once we have done that, then we rerun again. This might take a while, but once we have done that, there are so many things like, we measure the absolute error, so the difference between the plus or minus the difference between the predicted value and the true value. And there are things like root mean square, so the same thing, but the square root. So this is just to make sure the numbers are not exaggerated. There are things like, relative absolute error, relative square root. So these are mathematical methods to evaluate the difference between the predicted and the actual value. Once that evaluation is done, we're going to create an inference pipeline from it. Okay, so the evaluation model just finished. So if we click on the output and show the data, visualize, we can see different figures here. So if you see the mean absolute error is this much, the root square is this one. So this tells you how good or bad these things. For example, I know the coefficient is a range between 0 and 1. So the closer it's to 1 is the good one. So it's performing very well. If it's done. So the absolute error is like the plus or minus. It's by a factor of 0.25. So it's really predicting very well. So that tells you this is in a good state. So once you have this, then the next step is you have to create an interface pipeline. Oh, here you go. It's hidden here. Create interface. So I'm going to create a real-time interface pipeline. So this is for production purposes. So I trained it, I evaluated, I'm happy with the matrices, and now it creates a web interface. So it would automatically populate some stuff for you. So the first thing you need to do is, you need to rename this. So it's more of now, it's a predict car price. If I save that, then we need to instead of using the actual data, the automobile data, we need to have our own. You have to enter data manually. So you have to replace the data with enter data manually. So here, where is the auto select? So we don't need this data. And instead of this, we need the manual data entering, enter manual data. So we need to enter the manual data. So the web convert to this as it. So we don't need that. So we just want from here. So we select manually entering data and the web as well. So this is automatically added here. So here, the price shouldn't be there because we are going to accept the price. So we don't need that. And then remove the validation. We're not evaluating anymore. Yeah. So we have an output there. And then we have to execute a script. So we just enter some data here. It's a CSV data. There you go. So without the price, we have the symbol, the normalized, comma separated values. Save this. Python. So we have to execute a Python script here. So the score is going to execute a script. From a score, we execute a script. And then from here, we output some data here. So we finally output the script output here. So here, we're going to have some panda. So we're going to read the data, we score the level, and then we return a prediction. That's all we're doing here. Yeah, that's it. And then submit. Oh, it's failing somewhere. Yeah, predict price. So it might take a while. So this kind of shows you like how you train it, and then how you create a pipeline, an inference pipeline for getting to the next stage where you're gonna publish it using Kubernetes. The view details. Let's see where we are. I hope this gives you an idea of the steps to literally train your own model. So after this exercise, then the next step is to create a predictive service, the actual service. So this is a production service. So as you can see here, it's going through the steps, internet, and then the web. It's accepting, giving it some data, and also we are allowing to put some data. We select the columns, accept the price. Then we apply the transformation. Then we return the script and output it. So you have an input output like RESTful kind of design here. I heard this might take a while, so probably have to edit this video. So the process finished. So we are manually entering some data here. As you can see, we had 3 rows here. And these 3 rows, let's see what the price for these 3 rows is based on the MEC, the fuel, the aspiration, and the other data, the MPI and everything. So if we go back to after the actual output of the Python script we wrote, which returns the result of the score model, we can see the result set. Or for the first one, obviously we are the first one, not the second one. So we look at the result data set of the first one. And it's saying returning 3 rows here with the predictive price of this much. So 14,996, almost same. So you can see that it's predicted something for us. So it can accept manually. So we are preparing the inference model at this stage. So after we prepare the inference model, the next stage is to actually deploy to a production environment. So to deploy that, we need to click on deploy here. So when we deploy here, we have so many options. So you can say predict price, let's say car price, deploy, something like that. And you can use Azure container instance. So either we use Azure Compute or we use Azure container instance. So let's check if our endpoint is ready. So here it says it's healthy now. So if you want to consume it, this is the URL, the REST endpoint, and this is the key. So as you can see here, this is a code in different languages. So all you need to do is open a notepad, notebook, and if I create a file that says predict car price, and all I need to do is have a small script, like a Python script, and demonstrate an example here. So if I do this, so here I need to copy the endpoint. Sorry, here you go. Copy the endpoint here. So this is what you're going to use in your application or in your API. And then you have a production ready endpoint to predict a price. So here you have some libraries here. The data is about a car. It has fuel type, gas, it has a wheelbase, length, strokes, RPM. It's like what's a prediction. So all it is doing is, putting this data in a JSON file, create a header, and create a request. That's all it does to our endpoint, our training model. Then the trend models, and all it is returning the price here. So as you can see here, I'm going to use my cluster, right? So the prediction is done, and the price is now 14,907. So this shows you the actual result. It took some time. I'm not happy with that, but at least this is where you can train, evaluate, create pipeline, and then deploy for production. And then now you have an endpoint to submit any car attributes and return the equivalent, the resulting prediction based on the trained model. So this is how Azure Machine Learning does process data based on trained model. Thank you.